This video is about solving an equation using the elimination method. So remember the steps for the elimination method are first to line up the x, y, equal sign, and constant number. Then we multiply the variables to get opposite coefficients. So an opposite coefficient would be something like 5 and -5. Add the equations together, solve for the variable not eliminate, and then substitute the found value into either equation to solve for the other variable. So the difference with today is that we have to multiply both equations to get rid of our variable. Because right now, I can't multiply 2 by something to get to 3 or 4 by something to get to 5. So instead, I need to think about which variable I want to eliminate, which gives me more of a choice. And then I need to figure out what number do they both multiply to so that I can multiply both equations. So when I'm trying to figure out what variable to eliminate, it's probably easiest if you look for opposite signs. So y already has opposite signs, so I need to figure out what number do 4 and 5 both multiply to? 20. So I need to get both of those to 20y or -20y. So the first equation I'm going to multiply everything by 5, and the second equation I'm going to multiply everything by 4. I don't need to use a negative number here because I already have my positive and negative signs. So when you multiply, remember everything in that equation gets multiplied, so 15x plus 20y equals 30, and 8x minus 20y equals -76. So when I add straight down now, my y's are going to cancel out because I have 20 and -20. So I get 23x equals -46. Divide by 23, x is -2. Once we know x is -2, we need to substitute back into one of the equations. So I'm going to substitute back into the first equation this time. So I'm going to put x into the first equation. So I get 3 times -2 plus 4y equals 6. Well, 6 times -2 is -6 plus 4y equals 6. We can add 6 to both sides, so 4y equals 12, and divide y is 3. So our ordered pair would be -2, 3. In number 2, I can multiply either of these equations to eliminate a variable. I'm going to try to eliminate the y's this time because the y's have smaller numbers, so it's smaller numbers to work with when I multiply. So I know that 4 and 3 both multiply to 12. So I need to get both equations to either have 12y or -12y. So in the first equation, to get to 12, I'm going to multiply by 3. Notice I already have a negative sign in the second one, so I can multiply just by 4. So when I multiply in this equation, I get -36x plus 12y equals -24. And in the other equation, I get 36x minus 12y equals 24. So when I go to add this time, notice that not just my y's cancel out, the x's cancel out, and my constants, so I'm left with 0 equals 0. Remember, this is a special case. When 0 equals 0, that's a true statement. So our special case is infinitely many solutions. Number 3, I have 3x plus 5y equals 7 and -4x plus 2y equals 8. So I can eliminate either variable, so I notice that x has opposite signs already, so that's helpful. And I know that 3 and 4 both multiply to 12. So I'm going to multiply the first equation by 4 and the second equation by 3. So I can either get to 12 or -12 in front of x. So the first equation, I get 12x plus 20y equals 28. And in the second equation, -12x plus 6y equals 24. So when I add straight down, the x's cancel out and I'm left with 26y equals 52. When I divide by 26, y is 2. Now that we know y is 2, we're going to go back and substitute. So I'm going to take y, this time let's put it in the second equation. So we get -4x plus 2 times 2 equals 8. -4x plus 4 equals 8. I can subtract 4 from both sides, so -4x equals 4. Divide by -4, and x equals -1. So my ordered pair would be -1, 2. Now the next set of problems, notice that the x, y, and equal sign and the number are not lined up. So we need to do some maneuvering first before we can multiply our equations. So in the first one, I need to get y to be on the same side of x in the second equation. So I'm going to subtract y from both sides and rewrite these equations. So 4x plus 9y equals negative 10 stays the same. And I now have 2x minus y equals 4. Now that everything's lined up, I look and see, do I have opposite coefficients? Well, the y's are negative y and positive y, so they cancel out. When I add my equations, I get 6x equals negative 6. Divide by 6, x equals negative 1. Once I know x is negative 1, I can substitute back in. So I'm going to substitute into the first equation. 4 times negative 1 plus y equals negative 10. Negative 4 plus y equals negative 10. When I add negative 4 to both sides, I get y is negative 6. So my ordered pair would be negative 1, negative 6. In the second equation, in the second problem, the x is on the wrong side of the equal sign in the second equation. So this time I'm going to subtract 4x from both sides. So when I rewrite my equations, I have 8x minus 5y equals negative 11. And I have 4x plus 3y equals negative 11. So this time nothing cancels out right away, but I know that 4 can easily become 8 if I multiply by 2. So I'm going to multiply by negative 2 though, so I have my opposite signs. So when I add straight, or when I multiply, I get 8y minus, or 8x minus 5y equals negative 11, and negative 8x minus 6y equals 22. So when I add straight down, my x's cancel out, and with negative 11y equals 11. When we divide by negative 11, y is negative 1. Once we know that y is negative 1, we can go back and substitute into either equation. So I'm going to pick the first one again. 8x minus 5 times negative 1 equals negative 11. 8x plus 5, because negative 1 times negative 5 is positive 5, equals negative 11. We can subtract 5 from both sides. 8x equals negative 16. So when we divide, x is negative 2. So we get negative 2 comma negative 1. Number 6, there's a little bit more maneuvering we have to do in this one. So in the first equation, x and y are on the wrong side, so we're going to subtract 4x, and we're going to add 5y to both sides. And in the second equation, I need to move my x over, so I'm going to subtract 4x from both sides. So once I've done that, I can combine like terms. So in the first equation, I get 2x plus y equals negative 4. And in the second equation, I get negative 4x plus 2y equals negative 8. So in order to eliminate one of the variables, I'm going to multiply the first equation by 2. So when I multiply, I get 4x plus 2y equals negative 8. And I still have negative 4x plus 2y equals negative 8. So when I add these equations straight down, the x's cancel out, and I'm left with 4y equals negative 16. When we divide, we get y is negative 4. Once we know y is negative 4, we need to substitute. So I'm going to substitute into the second equation this time. 2 times negative 4 equals 4x minus 8. So we get negative 8 equals 4x minus 8. We can add 8 to both sides, so we get 0 equals 4x. Remember, it's okay if a variable is equal to 0, so when we divide by 4, we get x is 0. So we would have 0, negative 4. So let's look at a word problem and use elimination to solve. So in number 7, movie tickets at a local theater cost $6 for adults and $2 for children under 12. If 175 tickets were sold last weekend with cash receipts of $750, how many adults and children tickets were sold? So our variables, we have adults, we have children going to the movies. So there was a total of 175 people for $750. So to get our 175 people, we're just going to add the adults plus the children. To get our cash receipt of $750, we need to multiply each by their ticket price. So we have 6A plus 2C equals $750. So now to eliminate one of my variables, I'm going to decide to eliminate C. So notice that C has a 2 in front of it right now. So to cancel out with 2, we would need a -2. So I'm going to multiply the first equation by -2. -2A minus 2C equals -350. 6A plus 2C equals 750. So when I add straight down, the C's cancel out and I'm left with 4A equals 400. Divide and A is 100. Once I know A is 100, I need to go back and get my children. So I'm going to substitute 100 for A. So 100 plus C equals 175. So C is 75. So remember, when it's a word problem, we need to do two things. We need to write our answer as an ordered pair. So we have 100, comma 75 because we're going in alphabetical order, and we need to write a sentence to support the answer. So there were 100 adults and 75 children tickets sold.